All right, welcome. Today we're going to be digital architects. We're diving headfirst into the absolute basics of SQL, and we're going to build a database right from scratch. The best way to think about it? It's like we're constructing a house, but for your data, one command at a time. So you ready? Let's lay that first brick. So, have you ever wondered how your favorite app just remembers you? Or how a shopping site keeps your cart full even when you close the tab? You log out, come back a week later, and poof, it's all still there. How does that even work? Well, the magic behind all of that is a database. It's the memory, the foundation, the digital warehouse where all that information lives and breathes. And today, we're not just going to talk about it, we're actually going to build our very first one, step by step. Okay, first things first. Before we can even think about building walls or adding furniture, we need to claim our piece of digital land and pour the foundation. This is the absolute first step in our little construction project. It all boils down to these three commands to get started. First up, show databases. Think of this like surveying the land, right? You got to see what plots are already taken before you build. Then, create database, try one. This is you planting your flog in the ground, claiming your own plot. And finally, use try one. That's you rolling up your sleeves and officially starting construction on that specific piece of land. Pretty straightforward, right? So we've got our land. Now what? We can't just start throwing data around randomly. We need a blueprint. And in the world of SQL, that blueprint is called a table. It defines the structure, the rooms, and all the rules for our data house. Now, a super basic blueprint could look something like this. We're just creating a table called buttocks with two columns, a simple number for an ID and a space for a name. You could think of this as designing a studio apartment. It's functional, but really, really simple. But for any real-world app, you're going to need a much more detailed and robust blueprint. You've got to think about rules, constraints, and exactly what kind of data you're storing. So let's leave the studio apartment behind and design a proper house. First up in our professional blueprint is auto-increment. So we're creating an ID column, but we're basically telling the database, hey, you handle the numbering for me. Every time we add a new person, it automatically assigns the next number in line, 1, 2, 3, and so on. This gives every single record its own unique address. It's absolutely the cornerstone of an organized database. Next, we define a space for the first name. That varchar 50 part just means it's a text field that can hold up to 50 characters. But the really crucial part here is not null. This is a rule we're adding to our blueprint. It means this field has to have a value. I mean, you can't have a student without a first name, right? Now for the email field. We're again saying it can't be empty, but we're also adding this unique keyword. This is so important. It basically acts like a bouncer at the door. If someone tries to sign up with an email that's already in our database, the system just rejects it. It says, nope, already got one of you. This is exactly how you prevent duplicate accounts. Oh, this line is fantastic for automation. It creates a field that automatically records the exact moment a new student is added. We don't have to lift a finger to enter the date and time. The default current timestamp command does it all for us. It's like a digital security camera logging exactly when someone entered the building. And finally, this line. We already made our ID column count up on its own, but this command makes it official. Primary key ID declares that the ID column is the one true ultimate identifier for every single row in our table. It is the master key. All right, our blueprint is complete and the house is built. The foundation's solid, the walls are up, the rooms are all defined. Now it's time for the fun part, moving in our first piece of furniture, our very first row of data. So how do we actually do that? With this command, insert into. We're telling the database, go into the BATAX table and place these values into the columns we made, the number 3 for the ID, and the text DBMS for the name. So did it work? To see the result, we use select *esc, which is just a fancy way of saying, show me everything from the BATCHECKS table. And look at that. There it is. Our data is successfully moved in, stored exactly where we told it to go. I gotta say, seeing that first piece of data pop up is a fantastic feeling. Now, hang on. Before we get too comfortable, I want to share a super important pro tip for any new builder. See, there are two ways to move furniture into your new house. One is safe and reliable, and the other, well, the other can lead to total chaos down the line. And this is the core question we need to answer. When we just give SQL a list of values, how does it know which value goes into which column? Does it just guess? Does it rely on the order? The answer to this is critical for writing good, stable code that doesn't break. Okay, so this slide shows the two methods side by side. On one side, you have the safe, explicit method, where we clearly list out the column names we want to fill. On the other side is the risky, implicit method, where we just throw the values in and kind of hope for the best. Here's the key takeaway. When you explicitly list the columns, like first name, last name, you are creating a direct map. You're telling SQL, hey, listen, take the first value I give you, put it in first name. Take the second value, put it in last name. It doesn't matter what the actual table structure looks like. You've given it a crystal clear set of instructions. But if you don't list the columns, whoa, you're relying on a really dangerous assumption. You're just hoping your values are in the exact same order as the columns in the database itself. And what happens when a teammate, adds a new column right in the middle of that table tomorrow? Your code breaks. Or even worse, it might silently start shoving last names into the email column, just completely corrupting your data. It's a total nightmare waiting to happen. This table sums it all up perfectly. The explicit method figures out where to put things based on the order you define right there in your query. That's why it's low risk and highly recommended. The implicit method, it relies on the physical order in the database, which makes it fragile and high risk. Trust me on this one. Always be explicit. It's a habit that will save you from so many headaches later on. So there you have it. You surveyed the land, laid a solid foundation, designed a detailed blueprint, and moved in your first piece of data the right way. You've gone from just an empty plot of digital land to a structured home. Laying that first brick is always the hardest part, but now you have the fundamental tools. The only question left is, what are you going to build next?